Hello and welcome to another free code session. My name is Jason Bach, and in this special episode, I'm going to be talking about static abstract members in interfaces, which is a new feature coming in C# 11, and generic parameters. I want to make you aware of how this works so that you know with this new version what you can or cannot do with these two features in play. So let's look at some code. So let's say that you had a method like this. Now, this is a very simple method. It's something that you probably wouldn't write, but this is to illustrate the point. We have a method that takes one generic parameter, t, and within the method, we're not actually using t per se. It's not defining the type of a parameter. It's not defining the return type. So arguably, this should be something that actually takes a type, but this has been perfectly fine since C# 2.0. And I've seen this used in a lot of different places in code, both that either I've written or I've been on projects on, or that I've seen in packages on NuGet. So in this case, all we're going to do is get the type of t and return the name. So now I'm going to call the method with three different types: object, string, and iService, which is an interface I've just defined with one method, getData. If I run this code, what you'll see is we get three values back: object, string, and iService. This is expected. This is fairly simplistic. But here's where some things become interesting in C# 11. You'll notice now that I added a static abstract member to iService. By doing this, this third call here now has an error. And the error is CS8920. In fact, I'm going to grab the details on this, and we're just going to plop it in the code here, even though this is not correct C# code. But you can see that this is saying that the interface cannot be used as a type argument. Static member iService create does not have the most specific implementation. What this is telling you is that if you have an interface with a static abstract member, you cannot pass it into a type parameter. Now, if you want all of the details on why this is disallowed, you can take a look at this github.com issue. I'll have links to all the things I'm going to be showing in this episode in the description. But you can read this, it gets a little technical, and the hole that actually exists is a little bit of an interesting case. But the long and short of it is the C# team has decided that for C# 11, they're going to be very restrictive and say any interfaces with static abstract members cannot be passed in to type parameters. Even if you don't run into this hole or you don't run into this condition, and you're just simply using it as a way to pass in a type value. So how does this become problematic? Well, if you look at this code, this is one example. This is an interesting trick that I think somebody from the C# team showed me one time, which is you can use a type parameter as kind of a key value pair for a dictionary in a way. You'll see those first two lines of code. What I'm doing is passing in object and string as a type parameter and then setting the value accordingly. These are two distinct values. When I run this code, you see that we get those two values printed back. I'm not saying this is how you'd want to define a dictionary, but this does work. But as you can see, if I include an interface with a static abstract member, it no longer works. So if I had originally defined iService without it, everything would have been fine. But if I want to include that factory method on iService, I now have a compiler error. Another case is with a library that I've created called Rocks. Rocks is a mocking library, very similar to MLQ and NSubstitute, except that it uses source generators to generate all of the code underneath the scenes. For example, if I click on methods here and I go to the definition of that method, what you'll see is I have a bunch of classes that pass that type to mock around in method expectations and expectations of iService and so on. The method itself, rock.create, takes that mock type as a type parameter. So I generate all this code, create an instance of it, use it to call get data, and then I verify was that called the way I expected it to be. If I run this code, as you would expect, I get the value back, and verify doesn't throw an exception because the mock was used as the expectation was set. But as you can see, if I add that static abstract member, everything falls apart. I've been working on rocks to update it for .NET 7 and C#11, and this is one of the features that I actually had to address, because if you give me an interface that has a static abstract member, I have to do something with it. It was a challenge from a design perspective to think about how I would actually handle that for mocking, but I had to do something with it in the mock implementation. So I was working on it. I got to the point where I thought I had a reasonable solution. And once I finally ran my tests and I looked at the results, I was getting errors because of this problem. Using generics for rock create and all the expectation types would not work. Now, to be fair, language features can change some behaviors. I know we always hear about how a language feature, once introduced, is something that will be there in the future. And I don't think that changes here. But when you introduce a new language feature, that can sometimes change the landscape of what is currently going on within the language. For example, if I have an interface here that I implement on a struct, this all works. But in C# 7.2, the concept of a ref struct was introduced. So if there was a reason why I thought that my thing struct should now be a ref struct, and I define it as such, you can't do that. And that's because ref structs can't implement interfaces. So this will no longer work. And this is something that can happen. A new language feature may not work in the way that you think it would work with features that currently exist within the language. So how can you handle this? There's a couple ways to do this. One of them is to say, well, my interfaces should be defined in such a way that I have the static abstract members on one and all the instance members on the other. I personally don't like that. And in fact, if you look at interfaces that are being defined in .NET 7, for example, ibinary integer, you have a whole plethora of members being defined on that interface. For example, I'm looking over here to my right at my notes, and we're going to find these out. You see pop count, that's a static abstract member. You see rotate right, that's actually a static virtual member. You can do that in interfaces. That was before C#11. You can see we have get byte count. This is the traditional way of defining a member on an interface. And this forces the implementer to come up with an implementation. And we have a instance method that is actually what's called a DIM, a default interface member. So you can override this in your class that's implementing this interface, or you can just default to this implementation that is defined on the interface. So as you can see, interfaces have the capability of having very rich definitions. And so I don't think that's the right way to try to mitigate this or get around the problem. Another way is through the user actually creating a concrete type as a shim or a mock, however you want to describe that. But as you can see here, going back to my rocks example, I now have a class that implements iService, but leaves getData as abstract. So we can still do the things that we did before, but now we're responsible for saying that service to create has to be set to the mock before we would call create. And furthermore, rocks wouldn't even know that that exists, or wouldn't have to handle that being an expectation. If I would want to call this within my code, I'd have to have some way to set this up. Okay. But this does get around the problem of having an interface with static abstract members and passing that in to a type parameter in C#11. You have to make the caller, though, the user, do some extra work. So at the end of the day, is this a good thing that the C# team has decided to do? Quite frankly, I think at this point, this is set in stone. We have 2 months left from the time I'm recording this to when C# 11 is going to be released. And when I read all of the responses to this issue, I think the mindset that has been stated is, let's be restrictive. And if we find cases in the future that are legitimate, maybe we can open this up in some way so that we just don't completely disallow interfaces with static abstract members to be passed in as type parameters. But for now, it's just a blanket one and done. So if you think there are cases that are legitimate, then state them to the C# team, make your argument, make your statement, and maybe it will be deemed as something that they'll relax in the future. I do think this is the right way to approach it, in that if you're not entirely sure how you close this hole, then it's better just to restrict than to try to do something fancy or complicated that may not have a solid design in place that can lead to more problems in the future. An analogy to me, and this is not a great analogy, but an analogy I make is, if you're going to define a class that's public in a library and you don't intend anybody to inherit from it, then make it sealed. There's no point in letting somebody derive from that. Inheritance is a very strong form of coupling, and if you don't need it, don't allow it. But if you find out in the future that there's value and there's benefit in letting people inherit from your class, then you just take the seal keyword off. It's better to be restrictive and then open things up later than going the other way, because in that case, going the other way is a breaking change. And with something like this, you do run a risk to a certain degree of having something break in the future if you have things be a little bit more permissible. And that was the wrong decision to make. So this to me is something that I don't see changing to be allowed in any way with the final release of C# 11. So to sum up, what are the 3 things that I think you can do? One is to just eliminate outright in your API places where you have a type parameter that you're really not using that for anything generic, like you see in rocks with the create call. I could change that so that I'm taking in a type parameter, or not a type parameter, but a parameter as a type as my first argument. And then I'm going to have to do some other work to handle all those expectations that I showed before, because those are declared as generics. I'd have to come up with ways to make non-generic versions of those. Watch my channel in the future as I'm working on rocks for C# 11. I may decide to do that. I'm not sure right now. But that's one thing that you can do with your libraries. Another one is to do a separation on your interfaces with static members, specifically static abstract members, and other members on that interface. The third one is to create that kind of throwaway type or shim type that I demonstrated with rocks that the client or user would have to make, and that would be passed into the type parameter. I think what's realistic is not the second. I don't think that that's a good answer to this. I'm leaning towards the third and or the first. It depends on what you're doing in your libraries. The first one might be a little bit problematic because you'd have to add in another way of doing things. And depending upon how your APIs are defined, adding in an overload or something of that nature may not work. But it is an option, and I think that's somewhat realistic. The third one I think is probably the best way to handle these, but it's not entirely desirable either. I could see an opportunity here for somebody to write a code fix based on the error number of the compiler error that we get now with passing in an interface with static abstract members to a type parameter. You could create the code fix to say, generate an interface, generate a type that implements that interface and at least gives you the boilerplate code in place. And then you could take it and tweak it as you see fit. That might be a little bit of a way to alleviate that. But at the end of the day, there is no ideal answer to this. The fact is, this is the rule that's going to be in place in the compiler. And I wanted people to be made aware of this so that as C# 11 rolls out, and if you see this new feature, which quite frankly, I find is a very powerful feature, static abstract members and interfaces, that there may be some caveats with it out of the gate. That doesn't mean don't use it. I would say definitely look at it. Just keep in mind in certain cases that it may not work the way it has when you pass in that interface type to a type parameter. With all that said, I hope that this has been helpful. I'd like to hear your thoughts on this. If you think that this is a problem, or if you think that this is something that really is okay, it really won't bother you too much, or do you see this becoming very problematic in certain cases? But don't just let me know in the comments. I would also say let the C# team know. If you really have strong feelings on it, go to that issue that I mentioned. As of this recording, at the time of this recording, it's still open. Give your feedback. That's how you make your voice heard, and the team will read your comments. So please do that if you have really strong feelings on how this should work. With all that said, I want to thank you all for watching. Leave your comments and questions below. See you in the next episode.